number 49. Actually, that's number 46, which is a learning curve problem. We are told that the number of units produced is n is equal to 30 times 1 minus e to the k t. Same situation as we've been doing. We go through and we've got the initial conditions. So the initial condition states that after 20 days in the job, the employee produces 19 units. We're going to plug that into the equation. 19 is equal to 30 times 1 minus e to the k, which we don't know, times 20. Task here is to solve for k. So I need to isolate. 19 divided by 30 is equal to 1 minus e to the 20k. We want to subtract 1 from both sides. So this is 19 divided by 30 minus 1 is equal to negative e to the 20k. We're going to get negative 11 over 30. Getting a common denominator and subtracting is equal to negative e to the 20k. We're going to multiply both sides by negative 1 and take the natural log. We're going to have a natural log of 11 divided by 30 is equal to 20k. So k is going to be equal to 1 over 20 times the natural log of 11 divided by 30. Plugging that in the calculator. So plug in the calculator and get k is equal to negative 0.0501. So our model for this situation, because n is equal to 30, one minus e to the negative 0.050t. For part B, we're asked how many days should pass before the employee is producing 25 units per day. So the number here is 25. We want to solve this equation for t. We're going to divide both sides by 30. So 25 divided by 30 is equal to 1 minus e to the negative 0.050t. We can reduce 25 over 30 to 5 over 6 is equal to 1 minus e to the negative 0.050t. We're going to subtract 1 from both sides. We're going to get negative 1/6. Don't like that. So subtract 1 from both sides. We get negative 1/6 is equal to negative e to the negative 0.050t. We're going to divide both sides by negative 1, or multiply both sides by negative 1, take the natural log of both sides. So the natural log of 1/6 is equal to negative 0.050t. So t is going to equal the natural log of 1/6 divided by negative 0.050. Plug that in your calculator. T is equal to 35 T is equal to 35.8 days, which we round up to 36. So 36 days. Okay, so our last question, which is number 49, I believe. This is a logistics function, so P of t is equal to 1,000 over 1 plus 9 e to the negative 0.1656t. Now, you're given the graph in the picture. They're asking you to estimate the population after 5 months. Without estimating it, we can just find P of 5. You're going to plug that into your calculator. This is 1,000 over 1 plus 9e to negative 0.1656 times 5. Plugging that in your calculator, P of 5 is equal to 202.745, which, because we're talking about animals, is rounded to 203. Okay. The second part will be use a graphing utility, or after how many months will the population be 500? So we will be setting that equation equal to 500. So 500 is equal to 1,000 divided by 1 plus 9e to the negative 0.1656 times t. Our task here is to solve for t. So let's divide both sides by 100, or by 1,000. And we'll get 0.5 if I do that. So 0.5 is equal to 1 over 1 plus 9e to negative 0.1656t. We want to solve for t. T is in the denominator. It's also in an exponent. So let's take the reciprocal of both sides. This is 1/2. 1 over 1/2 is 2. So 2 is equal to 1 plus 9e to the minus 0.1656t. We want to isolate the term involving the e. We're going to subtract 1 from both sides. We're going to now divide both sides by 9. Again, we want to isolate the term involving the e so we can take a natural log of both sides. We're going to take the natural log of both sides. So natural log of 1/9 is equal to minus 0.1656 times t. So t is going to equal the natural log of 1/9 divided by negative 0.1656. We plug that value in the calculator. We get t is equal to 13.2, which is approximately 13 years.